Hi, I'm Maria Varmazis, host of the T- Space Daily podcast, and this is AWS in Orbit, building a resilient outernet. So we're bringing you the third installment of the AWS in Orbit podcast series today at the 39th Space Symposium. And in this episode, I'm speaking with representatives from Rivada and AWS Aerospace and Satellite about using the cloud to help build the world's most secure satellite constellation. Gentlemen, welcome.
Thank you.
Why don't we start with you, Declan? Can you give us an introduction, please?
Certainly. I'm Declan Ganley. I'm the chairman and CEO and founder of Rivada. We moved into the space arena just over a couple of years ago. We are deploying the outernet, Rivada's outernet, which is a low Earth orbit constellation of approximately 600 satellites at 1,050 kilometers altitude. It's a laser mesh network that has completely eliminated the need for ground relay stations, and that's what I'm doing at the moment.
No small thing at all.
That's really exciting.
That is
I'm
exciting.
really excited.
Right.
Really, this is amazing.
It is. I can't wait to hear more about this. Salem, tell us a little bit about yourself too.
Oh, about myself.
Yeah.
Well, my name is Salem Nimri. I work with AWS within the Aerospace and Satellite Business Group. And I look over all the subject matter experts in space globally. We are there to help our customers accelerate their ability to achieve their missions and meet their mission goals. And I'm really happy here to be joined with Declan from Rivada. They have a lot of unique solutions that they are bringing to the industry as a whole, and we're really excited. Thank you, Declan.
Fantastic. Declan, back to you. So give us the full pitch on the outer net that Rivada is building. I'd love to hear more.
You don't want the full pitch because we'd be here all day. But
Right, maybe a slightly shorter
I'll
pitch.
give you a corner of the pitch. So,
Okay.
so what Rivada is doing, Rivada Space Systems is doing, is we're putting 600 satellites up. But this is a very unique architecture. So for reasons that I won't go into now because it's a long story, but we have ended up with the highest priority slots to the Ka band globally. This is licensed by the ITU, the International Telecommunications Union. So this is a global spectrum allocation of Ka band, the 3Com1, 3Com3 filings. We have another filing called Outernet 1, which has also been filed. But we're launching 600 satellites. Our first precursor launcher goes up at the end of December or early January, depending on the weather and a couple of other factors. Each satellite has got a minimum of 4 lasers on it, but each satellite is a router, and there's a Goldilocks zone here of the 89-degree polar orbital inclination that we have, the highest priority to the Ka band, the fact that we're at 1,050 kilometers rather than 350 kilometers,
Yes.
so we have a bigger horizon, but we're still low Earth orbit. And what that combines to do is give you the lowest latency, fastest communications network over 4,000 kilometers on the planet. So over 4,000 kilometers, nothing will be able to touch us in terms of speed and latency. And because we don't touch the internet, which is why we call it the outernet, because we don't have to touch the internet, this is a system that doesn't use subsea cables, it doesn't use the same networks that even every other LEO satellite constellation has to use. We avoid all of that.
Yes.
All of the traffic is managed in space, and we're working with AWS to do that. So we can take a customer that's got a Rivada terminal from any point on the planet to any other point or multi-points on the planet without touching the internet. Nobody else can do that. That's
Yes.
unique. And there's a whole lot of new things that can happen with that type of capability.
Fantastic. So tell me a bit about why this is so important. Why now? Why the outer net? Why is this needed?
Well, the speed, latency, and security, those things are obviously hugely important. They have a premium value. There are sophisticated enterprise and government customers that place a premium on having those things, and they can't get it anywhere else right now, and that's nobody's fault. It's just that innovation has now taken us to the point where we can do this.
Absolutely.
Why now? Well, in terms of customers that are coming to us, and we've got over $7 billion of signed MOUs, so we have an order pipeline, if you will. There's a lot of things driving that fact. Rather than have a virtual private network, people can now have an actual private network. This is one network where they can, and if you're a government, you can have data sovereignty, you can have data security, you can, there's a lot that you can do with how you manage the traffic on this network. AWS, of course, is part of that. The fact that there are cable cuts taking place, the reported cable cuts by the Houthis in the Red Sea, the outage off Ghana very recently, and a really increasing threat to the global cable environment. There's over 500 subsea cables. It wouldn't take a lot if there was a state actor or a state-sponsored actor that wanted to go out and really mess with the global communication system and the internet. It wouldn't take an awful lot of effort to take it down. The outernet would survive an attack on the internet that took the internet down. The outernet will keep working, and it may be the only thing that does. So that's why it's important.
Fantastic.
And there are many applications. I would add, I will drop the word AI.
Oh.
I have to. I can't resist. When you look at
we'll
it,
allow it. It's all right.
It's basically, there is all these data lakes. It's going to be all over the place with data sovereignty that's going out there. We will start talking about distributed AI. And when it comes to all of this, connectivity, latency, being able to deliver the data on time, reliably, and securely, which is one of the uniqueness that we see here, because they are actually, with Rivada, they're using MPLS networks, which gives you a lot of efficiency in all the deliveries. That's important. And as we get into generative AI, this is really key, because we want to push everything to the edge. And by the way, congratulations on the patent awarded for generative AI.
Yeah, that's huge.
So Rivada actually was awarded a patent on generative AI. So congratulations, Declan.
Thank you. No, we appreciate it. That's we're very excited about it. We filed that patent before generative AI was a thing.
A sparkle in the eye. Yes.
Yeah, exactly.
Yeah, to get awarded, that's really nice.
Yeah, but the patent...
And at the right time.
Seriously.
The patent actually awarded, and it takes years to get these
Indeed it
patents.
does, yep.
So it awarded a couple of weeks ago from the US Patent Office, and it's using generative AI to manage a spectrum firewall to allow for masking, obfuscation, redirection, all sorts of
security,
phenomenal security features, cybersecurity features that you can put in now to applying generative AI to on in the spectrum management environment. So that's what the patent's for. Thank you very much. Much appreciated.
It's great to hear about a generative AI application for space.
Yes, indeed.
This is amazing.
With security added in too.
I mean, you have to add the security.
And if you look at quantum AI, and of course it's a big buzz right now, and it's something we've been looking at for a very long time, because the outernet, the quantum AI is great, but one of the things that will limit its greatness is the speed, latency, and capacity of its neurological systems.
Yep.
The communications link that join those quantum computers that the AI operates on. How are the synapses, how are the neurological links of that network going to exist? And there you need very high speed, very low latency, a low attack surface, and high security. And this network is made for that type of application. If you've got something that needs to be very secure, go very, very fast, have ultra low latency, this becomes the neurological, the synapses, the nervous system of the quantum AI brain. The outernet will become, I think, and Rivada thinks it's going to become a really central part of this whole quantum AI environment. So while people are looking kind of at the stuff that all the buzz is out there right now, it's the stuff that makes all of these things link up, that links all of these quantum computers.
Yes.
That really allows AI. What's AI? It's the aggregation and processing of almost infinite amounts of information
data
to produce instantaneous answers.
Yep.
You need speed, low latency, and connectivity globally to do that. And that's what the outernet going to achieve.
Yeah, and on the back
of
that, of course, we have AWS with all of our data centers. We are investing in making new chips that will enable customers to achieve their missions. We have our Inversia chips, and we have the Trainium chips for training AI and ML models. So we're really excited. Connectivity is key.
Yeah.
And this is why we look at connectivity and security is really
fantastic. Yeah, fantastic. We're already talking a little bit about how AWS and cloud comes in here. I just wanted to ask Declan, is there anything else about how AWS and cloud works with Rivada to enable your solution?
Well, without getting into sort of getting into too many secrets here.
No, of course not.
For example, one of the areas that we're working on is you have to be able to have a digital twin, digital simulation
Indeed.
of everything that the network can do. So the power of AWS and applying the processing power and everything else that they bring to that is frankly unmatched. And so for us, from a Rivada perspective, using the AWS cloud has been extremely useful in building a model that will emulate exactly what the real constellation does in real time. So if you want to go a particular, you want to use routing of a particular type, or you want to concentrate resources in one particular area, the AWS contribution and participation in this provides a very important element of what we're doing there.
Yes, and we're providing the infrastructure to run all of this. And the key word here is that it's a digital twin of the constellation. We're not talking about one satellite. Rivada is not sending one. They're
It's
sending
constellation,
600,
yes, indeed.
over 600 satellites, 638, I guess, if I want to be more exact. And that requires a lot of compute power and the finesse in how we do all of this to manage the traffic and to bring a lot of the uniqueness that Rivada is bringing to the table, whether it is routing data from one location in the Earth to the next, or trying to do some geofencing, or try to go over the polar regions for latencies. They really can do a lot with their SLAs. It's really exciting.
And that's the thing is with AWS, the multitude of unique applications and unique roles at the moment that Rivada can execute on, AWS helps us leverage those.
We are excited. I can tell you at Aerospace and Satellites.
I can tell.
all the engineers, they're like, Rivada, what they're bringing to the table, the uniqueness of their solution, the security, the way their satellites are meshed, the way the orbits are actually going around
It's
Earth.
fascinating. It's legitimately fascinating.
Yeah, because like, for example, if you have inclined orbits, you don't go over the poles, then there's no way to route over the poles.
Right.
But
it's a shorter path when you go over the poles.
You fly from Japan to London, you don't go round the...
No, you go way over.
You go over the top,
Indeed.
you go over the poles. Well, that when you have solutions and routing opportunities that can take advantage of that, then when you're not touching the planet anywhere and you're not touching a ground relay station, that's a huge game changer. Nobody else can do that.
It's quite amazing. I want to shift topic a little bit about how Rivada's outernet is going to be serving government intelligence customers maybe differently versus the enterprise customers. Can you talk a little bit about that, Declan?
Government customers have their own unique requirements. I mean, for example, things like our
geofencing, we just touched on.
The generative AI enabled spectrum management, which we have a patent for, as we talked about earlier, a new patent for, that governments have, and no two governments are identical in terms of what their needs are. And one of the beauties of what we can do is we can do a bespoke offering. We can give data sovereignty, data security, data residency, and global connectivity to a government that doesn't have to touch the internet anywhere. So if they want to link up all their embassies, if they want to link up all their ships, whatever it might be, without touching anything else, they can do that by connecting to the outernet and having complete control and full knowledge of where their data is and resides all the time.
Yeah.
And they can keep control of it. That data sovereignty piece that the outernet further enables is hugely important for governments in a way that it wouldn't be important for even big enterprises. There's an additional requirement there from government customers that we're seeing.
Yeah, and we see the same thing on the AWS side. data sovereignty and residency is important. That's why AWS is actually opening more data centers and regions, and we are really happy with the latest announcements in all over the world. So we are there to help our customers. We are here with Rivada, who will enable that by going through the outernet, which is exciting. So.
And to your point about data centers, and this applies to governments as well, to your government question. The governments that have data centers that are doing all that, those data centers are also highly vulnerable to a collapse of the internet, to the cutting of subsea cables. When you've got a Rivada terminal on top of that data center, the ability to connect to the outernet, bypass all of those subsea cables, that's very valuable to government customers.
I could absolutely see that. Yeah, absolutely. Salem, I wanted to ask you a bit, if you could talk a little bit more about this partnership between Rivada and AWS and how AWS is coming in with to help Rivada unlock capabilities here and do things more efficiently. Could you talk a little bit about that?
Yes, I mean, if you look at the Rivada customer base, they're trying to service different enterprises with different requirements and needs. When you're trying to serve governments with different requirements and needs, all of this needs to be taken into account when you're trying to manage that whole constellation and route the data and meet the strict SLAs that are going to be applied and the latencies. We are really simplifying a lot of things here as we are talking on this podcast, but I will bring it to this environment that we are in here. We're in this building. There is a room with routers. There are all these cables to hotspots. You really know how it's going to be at any point in time. What Declan touched on, the router for Rivada is actually the satellite, and it's flying at high speeds, 7.8 kilometers per second.
Yeah.
Technically speaking, in 5 seconds, it's looking over a whole different area. Mm-hmm. That capacity management, their network is actually, like, you can think about it as this fits like a lung. You're just breathing in and out, and the capacity of all of this. Satellites flying, Earth is rotating, we are driving all over the place.
A fun technical problem.
It's a fun complexity, and this is why we are excited about it. So we're doing a lot of these things. We're working closely with Rivada to basically understand the needs and try to make sure that all of these are met. And I'll tell you, working with their engineers is a breeze. We loved it. We loved it.
Yeah.
They have smart engineers, some of the smartest.
We've got a great engineering team. AWS have a great engineering team, and our engineers have developed a really good working relationship and a lot of respect for each other, I think it's fair to say.
It's really lovely. We like it.
Yeah.
That's wonderful. Gentlemen, I know we're coming up on time. I just want to give you both an opportunity to wrap up, leave us with any last thoughts, maybe visions for the future, long-term plans. Declan, I'll start with you.
It's hard to exaggerate the transformational effect that the outernet's going to have. You had the advent of the internet. The outernet is something very different. It's separate, and it's going to, not only is it going to enable new applications and uses, it will even end up enabling new industries. What this can do for governments, what this can do for big enterprise customers is going to be transformational. It's going to extend communications capability to every corner of the globe. And we think that we're going to see real economic impact everywhere that it comes into use.
We love it. I love it. And this is that uniqueness that they bring to the table is what we are trying to back up and basically enable with the AWS infrastructure here that we have on the ground. Your guys in the space, and we're here with AWS on the ground trying to provide all these resources for all our customers, which are mutual customers between both of us to basically reach out and do a lot more great things. So we're rooting for everybody.
Thank you so much, Declan, Salem, so much. Thank you so much for this great chat today. Really appreciate your time.
Thank you, appreciate it, loved it, thank you.
This episode was produced by Alice Carruth and Laura Barber for AWS Aerospace and Satellite. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our associate producer is Liz Stokes. Our executive producer is Jen Iben. Our VP is Brandon Karp. And I'm Maria Varmazes. Thanks for watching. Bye-bye.